I'm now moving to session one. Session one is entitled Green Deal Decarbonization by 2050 and the Key Role of Liquid Fuels. So we're having a keynote speaker, Mr. George Kremlis. George Kremlis, who I know for many years, he has been very active in the European Commission, where he worked there since 1981. He is an old hand in energy and especially legal matters related to energy and the environment. He has spent several years in senior positions, and lately he was also in the board of the National Center for Environment and Sustainable Development and the Regulatory Authority for Energy. And he is now the principal advisor to the Prime Minister on energy and environment. So, George Kremlis, you have the floor.
Thank you very much. Thank you very much, Costis. It is a real pleasure to be with you today. Congratulations for this very important today's conference, which is a very timely and a very important conference in this period of the implementation of the Green Deal. I would like to thank you, and I would like also to thank Jana for her substantial contribution in the organization of this today's conference. Now, let me share with you some thoughts about the subject matter of this session, which is an extremely important one. The Minister has referred to all the initiatives that Greece has already undertaken. I would like to place myself at the level of the EU, then go to the international level, and then come back to Greece to show the interconnection and the synergies between the three levels. And I would like to start by saying that the environment and climate protection has never been so high on the agenda of the European institutions. And this has happened with the von der Leyen Commission, this time with the Green Deal and the climate law. It is extremely important as it highlights the interconnection between the quality of the environment and the goal of the Green Deal for zero pollution, and the interrelationship between environment and climate, as the objective is by 2050 to have the EU climate neutral. And an important, let's say, milestone has already been achieved in the sense that the Council of Ministers has already agreed on the climate law. Of course, the co-decision procedure has not yet been completed, but what is important is that the 50% cut of the green gas emissions by 2030 is already there, which is an important milestone and which will be most likely confirmed by the European Parliament. Now, the Green Deal and the climate law are connected with the key political priorities of the EU, namely green growth, that growth has to be in line with the environmental and the climate requirements as an economic driver, creating green jobs. It is also connected with the blue economy, which is extremely important. How can we exploit the marine resources, sea and oversea and undersea resources, which is extremely important. And last but not least, it is complemented by the circular economy, which is now becoming the economic model, contrary to the linear economy that we have up to now, the economic model of the European Union, through also a climate diplomacy, and I would add the circular economy diplomacy to promote this model beyond the borders of the European Union and develop it also as a tool in the relations of our trade agreements and the neighborhood policy, but also in our agreements with all the other key partners. Let me now move quickly to the international level where we have the Sustainable Development Goals, and there clean energy and renewables are extremely important, and the protection of climate is also an emblematic priority. We have celebrated very recently the 5th anniversary of the Paris Agreement, and the good news is now that the new USA administration will join the Paris Agreement, and they will be present in COP26 in the United Kingdom. This is an extremely important development, and we in the European Union, but also in Europe, we hope that the presence of the United States as a key player will have a substantial contribution to the success of the follow-up of the Paris Agreement and to new commitments being undertaken. And now coming to the national level, where the minister has made a lot of remarks already, I would like to add that the National Plan for Climate and Energy, the ESEC, is an ambitious one with even more ambitious targets than the existing ones under EU law, which of course will be updated once the climate law will be adopted. The clean energy and the clean mobility is clearly there and is highlighted. And on the top of that, electromobility has now been developed and supported through a legal framework, but also other economic instruments to support it as, let's say, a green mobility wave that will be developing. I would like to add that it is extremely important that the Recovery and Resilience Plan refers and the strategy that has been presented to the European Commission, which is currently discussed with the Commission, refers to electromobility. And it is very important to develop further the ideas within this strategy, as there will be discussions between the Commission and Greece on how we can take on board liquid fuels. Jana has asked the question when introducing the program, can we reach the targets? Can we make the Green Deal happen without green fuels? This is a key question. And of course, green liquid fuels and green fuels in general have a very important role to play. And therefore, the recovery plan can put a lot of emphasis on, for example, hydrogen, liquid hydrogen projects. And in that respect, Greece could possibly become a hydrogen hub or start developing some pilot projects. Biofuel installations could also be developed, supported by the Recovery and Resilience Plan. And I would like to mention that in the Renewable Energy Sources Directive, there is already a 10% target to use renewables as the fuels. And in this context, biofuels have the most important share. Let me say that electromobility, if it doesn't use renewable sources of energy, and if you have electromobility and electric cars that are powered by lignite to be phased out ultimately by 2028, the added value is limited. Therefore, the connection with the renewable sources of energy, and in that respect, the biofuels that can also be blended with conventional fuels is extremely important. Let me add the last considerations. under the circular economy and the new rules on waste management, by 2022, we will have to collect separately bio-waste. And we have already seen in Athens the so-called brown bin, which is the bin where bio-waste is collected. This can be a source for energy, for biogas, for biofuels, for high-quality compost. And therefore, the mere fact that there will be a specific waste stream with bio-waste can lead to a new alternative source of energy that can improve the energy mix. I see that Koen Coppenholle is there. I guess he will refer to RDF and SRF being used as a fuel by the cement industry. In Greece, there are plans to build mechanical and biological treatment installations which will necessarily produce RDF and SRF. And of course, in the waste pyramid, this is preferable to landfilling, as the target for landfilling by 2035 is 10%. But of course, using biofuels is a form of recycling or energy recovery, which is higher on the agenda and the waste hierarchy pyramid. Therefore, it is very important to keep all this in mind. And last but not least, the roadmap, the circular economy roadmap of Greece, which will be updating the second circular economy plan of the European Union adopted in 2020, and referring also to waste as a source of energy, including green fuels. This roadmap will be soon made public for public consultation. This will be also a good opportunity to, let's say, take on board the findings of this important conference and see how we will be able to improve further this roadmap, as this roadmap presents a holistic approach on circular economy, lato sensu, going from waste and wastewater management to eco-innovation, to renewable energy sources, to electromobility, to energy efficiency, important topics that this today's conference will be covered. And this is also an opportunity to, let's say, raise the key issues that will be discussed today within this roadmap. And of course, seize the opportunity to improve further the strategy that we have already presented and which was welcomed by the European Commission in putting more priorities on this important Christmas tree. It's not a real Christmas tree, it has the key priorities, but we can develop them further to take on board also hydrogen, liquid hydrogen, and of course biofuels, which can further be supported under the recovery plan and also under the funds of the next programming period. Dear Costis, unfortunately, I have another meeting after my presentation. So should there be any questions, I am ready to reply in writing or later on, as you wish, as I will have to leave you in a while. At 3 o'clock, I will have to attend another online meeting. This is a very busy day, and I'm sorry, and I really apologize for having to leave you earlier.
Okay. Thank you very much, George, for this interesting intervention. You placed emphasis on the circular economy, and of course, moving to green fuels, it's a prerequisite that we go deeper into circular economy because of all the different components that are involved in green fuels. So green fuels are far more synthetic in terms of constituency than straightforward fuels. So very rightly, you pointed to the importance of the circular economy, and I keep this as a main point of your very interesting presentation. So we take note of what you said. So if there are any questions, we're going to channel them through to you, and we will seek you down and ask you. Don't worry. Okay.
Thank you.
So thank you again for joining us for this initial first session. And we now move on to our next speaker, who is Professor Pantelis Capros. Pantelis Capros, he's a professor of energy economics and operational research at the School of Electrical and Computer Engineering at the National Technical University of Athens. And of course, he was the first chairman of the Regulatory Energy Authority of Greece in 2000. He really set up the authority, and he put the founding stones of the authority. And everybody recognizes this and values very much his support to the development of the energy sector, and especially the energy markets. So Pantelis also is heading the scientific council of our institute, where all the committees form part, and we rely very much on his support and his advice in moving forward the various domains, the various sectors that we are engaged in at the Institute. So, Pantelis, you have the floor.
Thank you, Costis Stambolis. Thank you for the organizers for this invitation. It's a great pleasure and honor to be here. The topic is great and very important, and but allow me to broaden a little the scope and do not focus only on liquids, but also on gaseous. I believe that even the refineries in the future will broaden their production spectrum and will not concern only liquids, but a variety of biorefineries, hydrogen, green liquids, green gases, because they have the technology and they have, of course, the possibility to transform. It's very important that they are going to do that in the future, as the traditional oil sector is going to decline. We are talking about, of course, the context of the climate neutrality strategy, and allow me to say that since the beginning in the European Union, we have supported them, the European Commission, with very detailed projections into the future using our PRIMES model in all the kinds of roadmaps that have been produced, and very recently in the scenarios that have supported the Green Deals. And right now, we are supporting the Commission in all the revisions of the energy directives they are doing. And next June is an appointment for the European Union to present the full legislative package that will implement the roadmap to climate neutrality in real life. And it is about renewables, everything, renewables, hydrogen, gas, energy efficiency, of course, the targets and taxation, electricity, everything. So it is a very important momentum right now. We are full into the numbers about these projections. So I will give today a summary of the main issues of this strategy. When we talk about climate neutrality, we are talking about no greenhouse gas emissions and net zero CO2 emissions. It is about abandoning the fossil fuels altogether. And the strategy right now, as it has been consolidated, includes three major pillars: energy efficiency, renewables, and carbon pricing. the upscaling of the targets in 2030 has been already decided in the European Union. 55% greenhouse gases, something like 40% renewables, of which renewables electricity above 60% in 2030, a major, of course, restructuring of the power sector, and more than 40% in the energy efficiency. And in 2050, net zero greenhouse gas emissions. So we're talking about a roadmap here, which has the following fundamental ideas, which are, I believe, now fully consolidated in the analysis and in the decision-making in Brussels. First, and absolute priority, decarbonize power generation, mainly through renewables, storage, and a small contribution of nuclear and CCS where it is possible. Second, electricity as a zero carbon carrier penetrates the markets of transport and heat. This is the electrification. But where electrification is not possible or not cost effective, then the challenge is to produce green. It means carbon neutral, no carbon emissions, gaseous and liquid fuels to replace the current fossil fuels in these sectors. And this is a complement of electrification. How to produce those green, gaseous and liquid fuels? From biomass, of course, but limited potential, so it is not a full solution here. Second, electricity has to be the origin, and in particular, hydrogen from renewables. The other possibilities for production of hydrogen are not compatible with the net zero greenhouse gas emissions objective. Third, we have to find CO2 that is climate neutral also. And the only possibilities are from biogenic and then later from air capture technologies. And this combination of hydrogen from renewables and CO2, climate neutral CO2, is the raw material to produce the green, gaseous, and liquid fuels. And the fossil origins, if they remain in the system, must have underground storage of CO2, which, however, is today unavailable. It will be probably at limited quantities available in the future, but without that, they are not climate neutral. And the big concern in this strategy is the optimization of the overall efficiency, because the production of green, gaseous, and liquid fuels, unfortunately, is very inefficient and requires huge amounts of electricity. So to limit the increase in electricity, because this would challenge the potential of renewables and the potential of the electricity grids, we need to produce green, gaseous, and liquid fuels and hydrogen exactly where electrification is not possible. So we're not talking about replacing the entire amounts of today of gaseous and liquid fuels, but much smaller quantities, which will make the total electricity generation sustainable in the future. We're talking about doubling and more electricity generation in the future from today's levels, but despite this doubling, still the total amounts of green, gaseous, liquids, and hydrogen fuels will be limited compared to today's volumes. If we see a bit closer the supply features of the new transformation, here this is a summary of the process flow for the green, gaseous, and liquid fuels. There is hydrogen. There are origins green, gray, blue, and turquoise. We need CO2 from air, CCU or biomass. We have the route of hydrogen as a carrier up to hydrogen distribution to the end consumer. We have the chain from hydrogen to methanation, methane as a carrier. I talk about now climate neutral methane, and then gas distribution. Hydrogen as a carrier can be also blended in gas distribution. And we have the chain through methanol route or Fischer-Tropsch or olefins to liquid hydrocarbons and to liquids distribution, which is, of course, very conventional. Here, do not forget the blending of biogas in gas distribution and the blending of biofuels. They might be limited in terms of total volumes, but are the cheapest solutions and must take the first priority in the roadmap. The technology readiness is very unequal. The electrolysis has still to deliver significant scale economies, and the costs are expected to reduce significantly in the future. The methanation methanol route Fischer-Tropsch do not have fully the industrial maturity levels today. The CO2 capture from air is the most uncertain and immature technology, but it is of crucial importance in the future. The biogenic CO2 is feasible, but yet not ready at an industrial scale. Hydrogen distribution systems, including compression, liquid, and pipelines with hydrogen are feasible. However, investment is significant and it has to be planned correctly. The green gas blending is feasible in the short term. However, we need regulation, quotas for blending and incentives. I will emphasize on this point because, in my opinion, this is the first step towards the transformation. So green gas blending is possible, and the steam reforming of natural gas and CCS, which some industrial partners are promoting as a bridge technology, has a limitation of do not have available underground storage in Europe for CO2, except very specific cases in the North Sea. And a promising technology which is a complement to green hydrogen is gas pyrolysis, producing hydrogen and solid carbon, graphite. It is unfortunately not yet mature at an industrial level, but it is very important also to develop and complement the green hydrogen from electrolysis. The economic readiness is a challenge in this transformation for the gaseous and liquid fuels. Today, green hydrogen is 2 to 3 times costlier than gray hydrogen. Gray hydrogen is from fossil fuels as produced today, for example, by refineries. Blue hydrogen is not a choice, except in very specific markets like in the North Sea. The green hydrogen costs mainly depend on electricity costs, not so much on capital cost of electrolysis. And so it is very important to consider hydrogen produced by electricity when there is abundance of renewables, when they avoid curtailment of renewables. And at the same time, hydrogen has to be paid for the system services that it will provide in the future, because it will reduce very significantly the balancing costs, because the cycle of chemical storage through hydrogen and the liquid and gaseous synthetic fuels is of extreme importance for the stability of a future system of electricity with full of renewables. And that is the most valuable storage of electricity in the future. So benefiting from these storage revenues, green hydrogen can be competitive in a foreseeable future. Climate neutral CO2 is expensive today, more than 300 euros per ton of CO2, but there is a huge learning potential, and in the scenarios we assume that the cost will go down probably to 50 euros per ton of CO2 to produce from air. Biogenic CO2 is much cheaper, but the quantities are limited. The distribution and storage is feasible to develop. Careful planning is necessary, but there is no significant economic and technological limitation here. However, to trigger the process, the least cost route is to start with biomass origin of gas, liquids, and CO2. However, having in mind the total potential is limited, this will prepare the ground of passing from biological to the synthetic fuels. Looking at the demand features, the development of demand for this, I have here a picture of the most likely steps in the roadmap. I emphasize these initiatives which are on the left-hand side. It means of high priority. It is about conventional biofuels that however, have to be replaced by advanced biofuels. And here we are talking about lignocellulosic and Fischer-Tropsch technologies. The liquid fuel blending, of course, is practiced today, but it will be augmented through the blending of synthetic hydrocarbons. The first market to address is, of course, aviation and maritime, and this can take place even a little before 2030. And the biogenic CO2 can already feed the synthetic hydrocarbons, the green liquid hydrocarbons, and aviation and maritime in our planning is the first client for this purpose. And then it comes for the vehicles. The green chain here emphasizes on the importance of developing green hydrogen in the early stages of this process, and then produce specifically transport refueling hubs for hydrogen. The market here are the heavy-duty vehicles of hydrogen as the first step, and then also later on, a little after 2030, develop a specific application of large-scale hydrogen use in industrial sites, like in the iron and steel and others, including fertilizers and etc. And this hydrogen for heavy-duty vehicles can develop even before 2030. And then here down is illustrated the chain through the distribution of gas. And here is exactly the biomethane, the green gas blending, where small quantities of green hydrogen can be blended. Quotas are necessary for this to work. And then later on in the future, develop the fully green gas in all uses by blending now fully and transforming also the infrastructure to accept hydrogen at large scale and quantities of biomethane. And least, but not last at all, it is extremely important, is the electricity storage services by hydrogen, as I mentioned before. So the roadmap includes three main items here: the demand push strategy, the infrastructure priorities, and the economic incentives. The demand push strategy is by order of importance. First of all, the heavy-duty vehicles running on hydrogen, the quotas in gas blending, and the synthetic liquids in aviation and maritime. The infrastructure priorities are the refueling hubs, the infrastructure for storage, compression, and liquefaction of hydrogen, and later on, the distribution networks and the industrial applications in selected sectors. The economic incentives to make this happen is to start with demonstration plants, help subsidize the first industrial plants that are necessary here. The uncertainty is very huge to wait for fully the private sector to do on a merchant basis, full merchant basis, subsidize the vehicle purchasing costs for the heavy-duty vehicles, and make sure with a complex system of regulation that the quotas for blending are applied. For example, it may be an intelligent system of feed-in tariffs, like in the renewables of electricity, where bilateral supply contracts of blended gas are supported by the state, and costs are recouped from consumers based on the equality of the average cost of the blended gas in comparison to the natural gas in the early stages of this process. and this is the subsidy to eligible bilateral supply contracts, is a system that can work and can have the same multiplier effects as the feed-in tariffs in renewables in the electricity sector. A key word here is the RFNBIO, the renewable fuels of non-biological origin, because we are working in the forthcoming revision of the renewable directive called RED III, and the RFNBO are only be eligible for state aid and support schemes. A very complex and well-established system of certificates of origin will be fundamental, because today the legislation is very restrictive on hydrogen, on green hydrogen, because it requires additionality principle for renewables to qualify the RFNBO. But in the future, a complicated certificate of origin through the entire life cycle of hydrogen and other green fuels will be able to support the qualification of the RFNBO, which is the passport to get into the economy and the support schemes. And very important is that the revised renewable shares will include the RFNBO in the same way as renewable electricity accounts for the renewables transport share and others. And this is not only about monitoring policy, but also to support, to base support schemes on this. So this is a short summary of the way forward in the revisions of the renewable directives. We have developed, we have worked in the development of the Greek long-term strategy, which has been submitted officially by the Greek government 1 year ago to the European Commission, together with all the other member states. It has several scenarios. It aims at climate neutrality. And out of this, I could show some numbers for Greece, which are concern the most likely, so to say, scenario regarding the hydrogen energy balance in gigawatt hours here. And there is a range for 2030 from low to high. You may see the volumes already in green liquids and green methane that are developing. There is a question mark, of course, about the pace of this development. Normally, it follows the development of hydrogen in the first stages. There are direct consumptions with most emphasis in the beginning in the transport sector, of course, and later, of course, in all other sectors. There is a role of international maritime in the future and aviation. So we're talking about probably targets of having something like between 400 and 1,000 megawatt hydrogen electrolyzers in Greece by 2030, and then, of course, much more later on in the future. So this is, of course, preparations. There will be more elaboration of the Greek strategy for hydrogen and green gases and liquids through the committee that will propose to the government some concrete targets, demonstration plans and initiatives. It is a very promising route, and of course, we expect that the Greek industry will have the opportunity to invest and profit from these new prospects for the markets and the developments. Thank you, Costis, for this opportunity.
Thank you so much, Pantelis, for a very detailed presentation. Of course, your investment roadmap was very comprehensive, and I think it threw a lot of light into anticipated developments. The connection between advanced biofuels and synthetic hydrocarbon and liquid fuel blending, and the connection to hydrogen is really most clear in this presentation, which is not very well understood, I think, we don't yet understand very well this connection, but you saw this, I would say, quite clearly. And of course, your hydrogen balance for Greece, which I think we have several new pieces of information which came along with your presentation. I don't know how we would handle questions, but I would rather go over to our next speakers and then leave the questions for the end of the session. So I would now like to go to our next speaker, Mr. Koen Coppenholle. Mr. Coppenholle is the Chief Executive of the European Cement Association, CEMBUREAU, since July 2012. Before that, he was head of European affairs of ArcelorMittal in Brussels. And now he's representing here the Alliance of Energy-Intensive Industries, which is based in Brussels. So, Mr. Coppenholle, you have the floor.
Thank you very much, Mr. Chairman, and I hope that you hear me fine. Thank you for inviting me to this event. Yes, I mean, energy-intensive industries share quite a lot of the challenges, but I've been asked to make specifically today the case for the cement industry. So quite a lot of issues will come back that are relevant for more energy-intensive industries, but I will mainly focus on the cement industry, and within that, mainly focusing on the energy part of our business, even though we are very CO2 intensive actually in the production process, but I will come back to that. Maybe a brief word about the association. I will not linger too much on that. We cover most of the European Union, but we also have members outside of the EU, Turkey, Norway, Switzerland, and now also the United Kingdom. We have a cooperation agreement with Ukraine and the Ukrainian Cement Association, so very wide geographical coverage of our association. The cement industry, we like to think of the cement industry as a key contributor to the European economy. We have a employment of 35,000 people in Europe, a production annually of 180 million tons, which is 4.4% of the global production. China has more than 50% of the global production in cement. We have about 200 installations in Europe that are spread all over the European Union. And we are proud to say that we are really linking up to a larger sector, which is cement and then producing concrete. But concrete goes into the construction sector, which is a very large sector for the European Union. And there I would like to really emphasize the key role we have to play, not only in construction, the sustainable building, the renovation agenda under the Green Deal, we will play a key role there, but also the key role for our product, our end product, concrete, in the energy field. More and more wind farms are now also erected from concrete, not only steel. So we have a role to play there. We have a role to play in transportation, railways, part of that, but also transportation more generally, pipelines. So this is relevant for us as well. Maybe a word about how we address from the cement and concrete sector the Green Deal. We have issued in May of 2020 our European the contribution to the European Green Deal under the title Cementing the European Green Deal, where we have the ambition to become carbon neutral by 2050 along the cement and concrete value chain. So we're looking at the value chain, and you see it here with what we call the 5 Cs. We're looking at each of the stages of our manufacturing process, starting from clinker, going to cement, concrete, then what is our role in construction, and what is then the positive effect of carbonation, whereby we have a reverse effect of the decalcination at the beginning of the process of cement manufacturing at the end of life of concrete, where basically the CO2 is reabsorbed during the lifetime of a building, and especially also at the demolition phase of a building, where it is again exposed to the air and where the CO2 is reabsorbed. You see on the right side of this slide, for each of these stages, specific pathways to decarbonization that we have envisaged. with, not surprisingly, an important role for carbon capture and storage and carbon capture and utilization. I think this will become, especially between 2030 and 2050, if we can commercialize the pilot and demonstration projects we have, this is going to be a very important part of our decarbonization agenda. Again, I will not linger on that, but one of the most important things in Europe is that we need CO2 infrastructure and pipelines. I know that previous speakers were talking about hydrogen. Hydrogen is important, but I would hope that there is also space for CO2 pipelines, CO2 infrastructure, both pipelines and storage, which is essential for businesses such as ours. When we then focus on the energy specifically, and that's been the request for today, so I will not go into our CO2 part of the business, but still emphasize that if you look at the emissions of the cement sector, I mean, about 2/3 of our emissions are process-related CO2 emissions. 1/3 is basically focusing on the combustion emissions, but that's where I will mainly focus on. If you look at where the energy and the fuel is in European cement manufacturing process, it is mainly in this area where you have the production of clinker, which is our first product, where there's a decalcination process from the limestone. So the limestone is our primary product. The decalcination process happens in the kiln, and the kiln needs to be fired up to about 1450 degrees Celsius. The flame probably 2000 degrees, so higher than that, but then indeed a constant temperature in the kiln of about 1450 degrees Celsius. That's where, of course, the fuel will come in, and I will come back to that in a second. The other part is that we do need electricity as well, electricity especially when it comes to the transformation of clinker into cement. There is a grinding process. The grinding mills need to be driven by electricity, and I think that's where the electricity plays a role in our manufacturing process. Just to give you the background on the process. When you're looking at the electricity and the energy mix in the cement sector, electricity accounts for a stable share in the total energy mix of about 12%. And that's relevant for today's discussion. I think the fossil fuel is increasingly replaced by alternative sources, and I will come back to that. Alternative raw materials and alternative fuels. You see that the share of fossil fuels has decreased over time. The fossil fuels we use is petcoke, coal, a little bit of lignite that is there as well. But increasingly, we are replacing it with biomass and alternative fuels coming from different and a variety of waste streams. That's an important element in the cement sector. And before going there, I just wanted to highlight, as also the Prime Minister's advisor was referring to, that indeed in the waste hierarchy, the cement kilns are able to process what is called co-processing, which means that while producing cement, you have a simultaneous energy recovery and a material recycling. So we take in alternative fuels, we take in alternative raw materials that replace the primary raw materials, and we basically have at the same time an energy recovery and a material recycling. We will come to the type of wastes later on, but a good example is tires. Tires have energy recovery calorific value, which can make that they are the basis for energy recovery, but they also include iron, and the iron can be used to replace primary iron in the clinker production, and that is then material recycling. So we have both energy recovery and material recycling in the process. Therewith, we think that we really play a central role in waste management in the European Union, a central place, and at the same time, we can avoid CO2 by not using primary raw materials and primary fuels. We have now calculations that estimate that CO2 avoidance on an annual basis of 21.7 million tons. We are doing this calculation on the basis of the current level of alternative fuel use. Maybe just to make a side way into the circular economy, as the circular economy plan was discussed, I think it's very important to realize that Europe is only using 12% of recycled materials. So there's a lot of potential there to use more and to bring more into a circular approach and into an industrial symbiosis approach. If you look at the municipal waste generation in the EU, it's about 250 million tons per year. And the recycling on average is below 50%. You see some member states that are pretty high, but on the other hand, there are member states that still have a route to go. And I think that there will be a potential there to take up the recycling rates. If I take it back to the cement industry, we have used our alternative fuels in an increasing manner over the past years. We are now at 48% where we replace our primary fuels by alternative fuels. We come from 2% in 1990, and you see the amounts going up there gradually. What type of waste do we use? If you look at the thermal energy consumption by fuel type, as I said before, 52% remains the fossil fuels, but that is, and you saw it on the previous slides, declining gradually. We have now 31% use of alternative fossil fuels and 17% biomass. So the total amount is about 48% that we use to replace our primary fuels. What is the breakdown of these alternative fuels? Already referred to in the previous discussion. Refuse-derived fuels coming from a variety of industrial waste, but also commercial waste. Looking at indeed also pre-treating quite a lot of waste in the cement industry. We have mixed industrial waste, we have animal meal. So you see all the types of waste that we are using in the cement industry, and quite often indeed with also a pre-treatment to make sure that it is fit for the use in the kiln at the right temperatures. Moisture is an important element that we need to look at as well, but we need to make sure that we are operating in a safe way and safely operating also not only for the installations but also of course for our workers. So health and safety, a very important part in that whole assessment. This slide to just show you from an exercise we did is that there are cement plants in Europe and there is no technical impediment to increase our use of alternative fuels. There is a plant that is running at 95% alternative fuel. There is a possibility to go to 100% alternative fuel use. These are very high levels, and we aim to increase our 8% today to indeed much higher levels of 60% by 2030 and 90% on average in Europe by 2050. You see what it brings in terms of tons of coal equivalent being saved, waste being processed, and CO2 emissions avoided. This is something that is important for us and the direction we need to go as a cement industry. I will end my presentation. I will ask to talk to about for 10 minutes, so I hope I stay within my time limit. But I think it's important to look at the options that we have and what are the policy needs for each of these options. So I've emphasized quite a lot the use of alternative fuels, alternative raw materials. That requires, of course, that we have continued access to waste streams, that we are going as much as possible to a landfill ban of recyclable and recoverable waste. I think there's still too much landfill at this stage, and I know that this is not an easy discussion with some of the member states, but the landfill ban is really essential. And indeed, we need to look at national barriers as well. What we found in studies we carried out for alternative fuel use is that landfill ban is something that can be decided at European level, needs to be implemented nationally. But many of the impediments are local or national in nature. It's about permitting, it's about public acceptance, it's about taxation. So these issues need to be addressed in terms of access to alternative fuel going forward. Is electrification an option for us? This is challenging because of what I explained before. There is a high flame temperature reaction, 40-50 degrees Celsius. There are technologies under research right now. Plasma technology is one of them, but we are treading cautiously when it comes to electrification. It's very much at the research stage at this point in time. I do want to emphasize, and coming back to alternative fuel use, if we move more in that direction, or even if we move in the direction of carbon capture, we will have an increase in electricity demand. So electricity costs becomes a very important part of our parameters. Decarbonization means that we need more electricity from renewable sources. So that's going to be an expensive part, and an increasingly expensive part of our business. Hydrogen is being looked at. You probably saw a few projects being launched by some of our companies for partial use in the fire kiln, to fire the kiln. Partial use because it is indeed in combination with biomass waste. In some of the projects, because we need to assess the impact of hydrogen use on the physical aspects of the kiln, the mass flows, temperature, etc. And then indeed we are also using and looking at CO2 use, as I said before, for methane application, algae applications. We're looking at indeed mineralization of CO2. These are important applications. But I just wanted to highlight that for the cement industry, this is the path we set for 2050. Maybe coming back to all the energy intensive industries, there are more energy intensive industries that have need for access to feedstock that can be delivered to them by other industries. And I think that the industrial symbiosis between cement, steel, chemicals, petrochemicals, refineries will become much more important going forward. We need to look at each other's sectors to make sure that we can use the end of waste of one sector as an input for another sector. That's one thing I wanted to highlight. The other point that I wanted to highlight is that we're all confronted with CO2, which is in one way or the other process related. So we will need to make sure that we can capture the CO2 and that we can then transport and store it. That's a common challenge. And I think the infrastructure for CO2 is not only a cement industry only request, it's a request from more energy intensive industries. In addition to the fact that carbon capture and use is also something not specific for the cement industry, but is relevant for more industries. And there again, I would hope that we are having a close look from a regulatory perspective into how to account for the use that we make of the captured CO2. So I would end it there, Chairman, as my contribution to this debate, but thank you very much.
Okay, thank you, Koen. Thank you very much for a really very interesting presentation. Nobody would have thought that so much energy input is involved in cement. I knew that energy is important to cement, but actually you broke down the whole process very clearly. So we see how important it is to take into consideration the energy element now in industry, hence they're called energy intensive industries. And we just saw one example in the cement industry. Quite rightly, at the end, you pointed out all the different energy-intensive industries. So I think this throws a lot of light into the complexities involved when it comes to the industry, which uses a variety of fuels. Most relevant, and thank you very much for a very clear presentation. So now we move to our next speaker, and as I said, we'll take questions afterwards. So now it gives me great pleasure to welcome my old friend, Dr. Leo Drollis. Dr. Drollis has been involved in energy and oil for many years. He used to head the Center of International Global Oil Center in London for many years. I have attended several interesting events there and great work. And now he's taking, I would say, a longer-term view of the energy market as a whole. And I'm sure that you will have a lot of interesting things to tell us in today's colloquium. So, Leo, you have the floor.
Costis, and thank you very much for your invitation. I have been with you on many occasions, and we have discussed many things at your conferences. It's also nice to see Pantelis as well, and I'm glad to see him too. I must say, ladies and gentlemen, that I feel like a Christian in the Colosseum in ancient Rome, facing the lions. I'm an oil man, and I'm surrounded by green enthusiasts who hope to issue us into a brave new world. So I just want to bring us back a little bit to the current old world in which we live, and to discuss certain matters that relate to oil, which is my own business that I've been in for over 40 years. The question I'm asking is, oil past its peak again? I happen to have been part of the debate many years ago on whether oil had reached its peak from the supply side. That in other words, there was a big discussion and many views that oil was running out. And I remember taking the opposite view, that oil wasn't running out, would be unlikely to run out. And in fact, there's so much oil, we don't even know how much. I think my view and others like me won that debate, but now we're facing a new issue, which is oil reaching a peak from the demand side. And this is what I would like to address slowly today, I hope as concisely as possible. So if I may start by paraphrasing Sir John Templeton, who said that the four most dangerous words in investment is "this time it's different," I would like to substitute the word oil. And you know what the gist is of what I'm saying there. That people are saying this time it's different for oil, it's different for the hydrocarbon energy industry. The discussion points I would like to cover, we all know what happened last year, and the pandemic, the COVID-19 pandemic, is the most serious problem the world has had to face really since the Second World War. These severe restrictions on our movements still remain in place in Europe and other parts of the world. Vaccines may prove to be a game changer, but can we really be sure? I'm not certain. I think many people are a bit worried about that. Global oil demand has recovered from a truly devastating blow. It declined by 18 million barrels a day, or roughly 18%, in the first half of last year. But it is still 6.6 million barrels a day less than its level at the end of 2019. And the question here is, will normal service be resumed? And when will that happen, or will it indeed happen? OPEC, as you know, is the cartel that sits at the center of the oil industry and controls to quite a large extent the oil price. And the question we are facing in the business and generally in the world is whether OPEC and its newfound allies will respond to the need for more oil as the world economy returns to growth. And the key question here for them, and for us too, is what level of oil price will satisfy OPEC and its allies after the fiscal horrors caused by the recent price crash last year in April, May. US crude oil production is already up by 1 million barrels a day since its recent trough in May 2020. The question there is, will it carry on rising? And finally, at sort of the more technical point for the oil industry is, how soon will the global stock cover, which reached very high levels, how soon will it return to more reasonable levels? Because when it reached very high levels, the price of oil, as you know very well, crashed. Of course, demand was the cause, the collapse in demand. So before I go back to oil, I'd like to just show you this graph of climate change and CO2 emissions, just to remind ourselves of how much has been achieved in certain areas of the world, but not for the world as a whole. Since the signing of the Kyoto Protocol in 1997, the world's CO2 emissions, the black line you're seeing there, have continued to rise at 1.8% a year, largely, as you can see from the graph, due to the non-OECD countries whose emissions rose at quite a robust rate of 3.5% per annum. The success stories as far as reducing emissions of CO2 were, of course, in the EU, as we all know. The reasons, of course, for that in the EU is more restrictions coming in on hydrocarbon use by various means, and that has been reasonably successful. So the European Union's emissions have dropped over this period by 1% per annum. The US also has managed to reduce its emission levels of CO2 by 0.5% per annum, but the success of the US in doing that is mainly due to the increasing use of natural gas in the economy because of the cheap price of natural gas after the great shale gas revolution, the great discoveries of shale gas. So that's the actual picture where we are at the moment. I haven't included 2020 data, but first of all, because they aren't fully available. And secondly, because 2020, as we all know, was a very, very unusual year. And we hope we don't return to those conditions prevailing then. This graph reminds us how important hydrocarbons are at the present. Again, it refers to 2019 because 2020 was a very unusual year. At 33%, the world's dependence on oil exceeds all other fuels and has done for as far back as I can remember, certainly since the Second World War. And the share of hydrocarbons in total, including natural gas and coal, weigh in at just over 84%. So we are highly dependent, looking at the world as a whole, not looking at particular parts of it. We're highly dependent on hydrocarbons. In the European Union, again, we have quite a big, heavy dependence on the hydrocarbons. But of course, as you can see there, renewables are playing an increasing role. I've included Greece in this graph and Italy. Greece and Italy are quite similar in general, both Mediterranean countries. Italy, of course, is much larger and has a much greater population. But I wanted to show you that Greece still has a very high dependence on oil, the highest in Europe at 59% in primary energy, because of its heavy use of oil for space heating alongside the more traditional usage of oil for transport. Greece's gas and hydro share are relatively low, whereas in renewables, Greece is doing quite well because it's quite near, in fact, almost near the EU average. Greece has been slow in developing its natural gas as a source of space heating. And you can see there that Italy is far ahead. Italy, of course, produced some years ago quite a lot of natural gas. Their production is declining. So there is a lot of room there for Greece to improve its usage of natural gas, especially in space heating. And of course, to reduce its heavy dependence on oil, which of course has very much balance of payments repercussions for Greece. The world has masses of oil reserves. It has 50 years at the moment of oil reserves, known oil reserves, identified oil reserves, 50 years of production based on 2019 production of oil. So there is, if we were in a normal year, we have at least 45, 50 years of oil left. But of course, this doesn't include further discoveries. It doesn't include extensions and revisions to reserves, which are one of the driving forces of oil, the oil complex. Global oil output, as you can see from the graph, has been below world oil reserves since 2007. So we've been on an increasing level of reserves to production. Turning to primary energy consumption per capita, as you can see, in gigajoules per head. The point of this is to show you that world primary energy as a whole, including all the fuels, fossil and non-fossil, is growing at around 1%, or has been growing since 2000, which is quite a steady growth rate. There have been a few dips, but generally speaking, around 1%. The primary energy consumption per head has been declining in the OECD, largely due to efficiency gains. But the non-OECD part of the world has continued to need more oil per head. Sorry, I beg your pardon, more primary energy per head. The EU's primary energy consumption has been declining. But the key here is that there are parts of the world like Africa where there is a huge potential for energy growth in energy consumption per capita. Africa's consumption per head is 20% of the global average. So there's a lot of scope as Africa develops over the coming years. And the Asia-Pacific region, which we all know is one of the engines of growth of the world economy, there, energy usage per capita is still 34% of the OECD average, or the developed world's average. So again, in that region, despite its substantial development already, has more to go. So there is a lot more consumption of primary energy likely to occur, increases in consumption in the world as we move ahead. Here, I want to show you some work I have been doing over the years, trying to predict global oil consumption. Here I'm showing you the result of projections using a dynamic equation driven by two factors, really, real GDP and real oil prices. And the explanation is pretty good, because the average error predicted versus actual is only 0.5% over this whole period. And if I were to use this analysis to project oil consumption to 2030, it's more of a business as usual kind of scenario. I'm assuming that Brent averages $55 a barrel, and world growth is lower than it has been at 2.5% per annum from 2022 onwards. I'm assuming that I'm looking at the future beyond 2022 rather than incorporating 2021 this year and last year's a very unusual year. It yields an oil demand growth, this picture of 1.3 million barrels per day, which is quite a reasonable growth in oil that perhaps many people might find unacceptable. But based on what has been happening, this is a likely scenario, which is not too bad from the oil industry's point of view. So let me conclude by reminding us about certain fundamental truths in oil. We know that more oil tends to be forthcoming where producers of oil are free to respond to price stimuli. OPEC, of course, as a cartel, engages in efforts to raise the price of oil. But of course, this leads in due course to more oil being produced in, for example, the US and elsewhere. Higher prices tend to lead to more production in free economies and without cartels. Let us remind ourselves that oil demand is certainly not price elastic, but it is not completely inelastic either. This means that oil consumption does respond to lower oil prices given time. There are time lags involved. In the developing world, oil demand is bound to be stimulated, in my opinion, by oil around the $30 to $40 per barrel level. We can discuss it if you like in questions and answers, but that is my view. However, the oil business, as you know, and I do, and we've heard a lot today about it, oil being a hydrocarbon, it faces significant headwinds from the green movement. A determined effort directed towards zero carbon use by 2050, which is certainly the EU's objective, would hit oil demand hard. If it were at a global level, it would devastate the oil industry. In view of the world's massive known oil reserves and growing restrictions on oil use by government fiat, we must remind ourselves here that governments in the European Union in particular have been restricting hydrocarbons by fiat rather than allowing the markets to develop it, to evolve unaffected. Oil prices will come under sustained pressure and demand will respond somewhere in the world. This is my view, and I think it's a logical one based on what I've shown you and what has happened over the decades. So, logically speaking, to conclude, oil should peak from the supply side sometime in the distant future, unless governments ban its use. My final question, a rhetorical one, of course, is why prohibit people from enjoying a resource that has so much yet to give? Thank you very much for your patience, and thank you for inviting me to talk.
Thank you, Leo, for an excellent account, as usual, very clear. As you said, the message is clear. Many people may not like the message, but this is the situation as it has been developing and as it is today. So the question is, what happens from now on? And I think we have about a quarter of an hour to discuss the observations and findings of this session. And let me point out of the apparent antithesis, contradiction, which we have at present. As Leo showed very clearly, we have increased demand and supply, despite the slump of last year and early this year. It seems that the oil market is recovering. So we have on the one hand abundance of supply, maybe even higher prices. So if you see it from the oil market's perspective, we see that the situation is gradually returning to a normal with demand and supply fundamentals working. On the other hand, we have the pressure from a policy level from the EU and now from the US to lower emissions and therefore oust oil and gas. But this is not happening. I mean, this has been discussed and instituted to a certain extent over the last few years. We see a big inroad of renewables, but yet we cannot see any visible curb in terms of the input of oil and gas. So we have an antithesis here. Pantelis Capros explained very well the mechanics of the next generation fuels and hydrogen and all the solutions that are there, and there are workable solutions. So he talked very much on what can be achieved. And of course, he put emphasis on the price. Mr. Coppenholle demonstrated in one particular industry what the challenges are. Kremlis, who left us, he pointed to the circular industry, the circular notion of the economy right now, and how this is going to enhance the road towards zero emissions. Something which also the chairman of the Technical Chamber of Greece alluded to when he described the roadmap to 2050. So I think in this session we have managed to see both sides of this huge debate. And in the middle we have the oil industry, which says, look, fuels are going to be there for the next few years. So what we can do to lower emissions is to produce a new generation of fuels based on biofuels or synthetic fuels, and hydrogen coming into this equation, and we'll do our best to lower emissions. So the question is how we go on and what we can see happening really in the actual field. I mean, are we as consumers in 2 or 3, 4 years go out and enjoy the benefits of hydrogen and the benefits of electric cars and zero emissions? Pantelis, could you please comment on this?
Yes. I wanted first, Costis, to comment on Leo Drollas' conclusion. You know, since many years, I admire the presentations of Leo. And the first time I met him, probably he don't remember that, I was even a student in France where I saw his lecture on econometric equation of forecasting gasoline price. It was, I remember, in Lille, and it was admirable. And I would fully share the conclusion of his presentation if we had not the negative externalities from the fossil fuels. Of course, we would forever enjoy this industry and the fuels. However, we are facing a major negative externality. And in economics, when there is a negative externality, the state has to intervene, and this is about, first of all. The second, however, evolution here is different. The European Union today takes the climate challenge as an opportunity to revive the industry in Europe, to stop importing and produce domestically instead of producing oil and gas, to produce equipment, to produce chemical substances, to produce electricity, to produce everything which is needed. And this, I believe, evolution towards a domestic industrial economy in Europe, supported by this Green Deal, is in reality today a major movement that cannot go back because of the expectations of economic benefits. And to add to this, the major issue, the major policy of the CBAM. You know what the CBAM is? A cross-border adjusted mechanism. We're doing the scenarios for the European Green Deal for the CBAM. And it is the first time since many years that a region of the world consider imposing duties, in reality, taxes on imports based on this Green Deal concept, on everything, including electricity, including hydrogen, including the industrial products of the energy-intensive industries, in order to make the economy, the domestic economy of the EU grow. So we cannot neglect this tendency. And from a Greek perspective, we have to grasp on this because it's an opportunity. So it is not so much about consumers enjoying hydrogen or green molecules or renewable electrons. On the contrary, many of them will be more expensive than today consumption, and there will be subsidies, and there will be subsidies recovering funding from consumers. So it is a burden in reality from a consumer perspective. The benefit is in the new business it creates and in the replacement of the old business, of the creative destruction that is going on. That is one point that I wanted to emphasize on. This is about. Coming to the very important discussion of about the prospect of energy-intensive industries, and in particular cement, but also iron and steel, etc. In our scenarios that we are doing for the Green Deal, we do include carbon capture and storage as a major option, in particular, first priority, to manage the problem of process emissions in industry. I didn't mention that, because it was out of the scope of this presentation today, but it is an essential component of the strategies that we are quantifying for the European Commission with the PRIMES model. However, the policy challenge is very big now regarding the acceptance of underground CO2 storage. I believe that as long as this storage stays limited in terms of total volumes, with priorities to those emissions that cannot be avoided through a different way, that amounts of CO2 storage underground and the CO2 transport infrastructure will be accepted in the foreseeable future.
Okay. Pantelis, may I interrupt you?
This is my second point. Thank you. Okay. No, I just finished.
Okay, because very relevant to what you just said, we have a question on this very point, which is addressed to Mr. Coppenholle. And the question is, how mature is cement industry at carbon capture storage and an alternative usage as block material? So, Mr. Coppenholle.
Yeah, I mean, thank you for the question, because it allows me to also come back on the previous speakers. I think that I agree with both of you, because actually what is happening, it's a process, and that will take time. I mean, oil is there in the markets, is established. I think what we have is major challenges ahead of us, and that includes heavy investments and developments in new technologies. I mean, carbon capture is a breakthrough technology, and to come to the specific question, we have now a number of pilot projects and demonstrator projects on capture technology. These projects will be hopefully finalized by 2030. Now, we do not foresee commercialization in the cement sector of capture projects before 2030. The commercialization will happen between 2030 and 2050. That is why we have a 30% emission reduction target by 2030 and 40% over the value chain, but not the big jump till 2030. 2030 is around the corner. So I think the main gap and the main move will be between 2030 and 2050, if indeed we need to move to carbon neutrality. And then I want to come back, if I may, to the two other points that were made. I think this is requiring huge investments in Europe. And there are indeed still regulatory uncertainties, including around what will happen on CO2 infrastructure, what will happen on CO2 capture, etc. Will there be funding available? But also, is there going to be an equal cost base between European producers and third country producers? And that's where the CBAM comes in, indeed, the cross-border mechanism. If we want to do the major investments we have now, we have to make sure that we have a legal certainty to do these investments. We have long-term investment cycles, and we want to make sure that we do that on a horizon which gives us that level playing field and that equal cost base. We don't want an advantage, we just want an equal cost base. And I think that's an important element in the whole discussion. And indeed, last point maybe when we're talking about carbon capture, we are more and more increasingly also looking at carbon use, not only capture and storage, but also capture and use. But it will always need to be a combination of storage and use. And use at this stage is percentage-wise much lower than storage possibilities. So exploring storage offshore, onshore remains indeed a big challenge going forward.
Okay, right. Thank you very, very much, Mr. Coppenholle. Very well said. I have a question for Leo Drollis. The question is, if the environmental policies come to action, why the oil demand? I mean, where is the oil demand going? Which refineries are going to survive? So what happens, Leo?
Yes, thank you for the question. It's a good one. As you might have noticed that I mentioned the whole world. I was looking at the world as a whole, not the EU. In the EU, I don't have great hopes for refining in the longer term, unless they produce specialty products. One example is asphalt. How are we going to repair our roads and resurface them? That's just one example. But the world is a large place, and the rest of the world, apart from the EU, is growing more rapidly and has been for some time now. And there are parts of the world like, as I said, I mentioned Africa and let's say South America, which are way behind, and they will seize any opportunity to emulate the developed world and to grow substantially themselves. Now, they know that oil and gas have played a big role in giving us our civilization as we know it now. So are you telling me, or is anyone telling me, that with a low price of oil, why? Because there's an abundance of oil, that they will say, no, we're going to go into these highfalutin modern technologies in order to grow, which are expensive technologies. I really believe that this is not going to happen. And somewhere in the world, there will be the need for oil and gas. I believe this fervently. And may I add just one thing, not to this question, but there are a lot of statements made and these modeling that, I'm a modeler. I've done a lot of modeling in my life, especially simulation models. And Pantelis I have a great respect for in his modeling. But it's easy to do it when you don't have a reality impinging on it. I just have one problem with, for example, the use for Greece of electricity to drive electric vehicles. Let's say they do it by windmills, wind power. I just wanted people to know that 1 2-megawatt wind turbine, which is a large turbine, it's not a small one, is in a whole year can provide electricity for 1.89 vehicles, cars. We're not talking about trucks or other vehicles, but just cars. 1.89 cars, almost 2. 1 2-megawatt turbine for a whole year, assuming that the drivers drive 11,000 kilometers per annum. Now, the number of turbines I calculated needed to provide electricity for a complete switch to electric cars in Greece. Greece has about 5 million cars. To do that, you require 2.6 million turbines, 2-megawatt turbines, 2.6. Do you know how many turbines Greece will have by the end of 2020? 2,587. So there's a little bit of, we haven't reached there, but it's coming.
Okay. All right.
So can you imagine a 1,000-fold increase in the number of turbines to supply electricity for just cars, let alone space heating and anything else, and industry? I think it's absurd. I don't think people have really realized what is entailed and how much investment is needed. And who's going to pay for that? There's only one payer, the final consumer.
Okay. Thank you, Leo. It was a very interesting point you raised. I have a question, a very practical one. And I think this is mainly addressed to Pantelis. And the question is this. Greece and other countries in the region are investing in natural gas infrastructure projects. How much of this infrastructure could potentially be reused for hydrogen or other green fuels? Pantelis.
Yeah, I think it is a very important question. We recently delivered a very detailed study on this, financed by GIZ for Greece and another one for the European Commission. It turns out that the topology of the gas system will have to change. The inputs, the injection of gases, of new green gases into the system will take place in a decentralized manner, and also the security gas and the storage of gas must have a different organization and a different topology. Institutionally, it's going to be a very important role of the distribution system operators for gas, which have to be recognized and cooperate on equal basis with the transmission system operator of gas, which is so it's a very different institutional organization also. in a steady state, all this infrastructure could be converted and could be used for hydrogen, but the topology, the organization, and the additional infrastructure that's going to be needed is considerable.
Okay, thank you very much. I think we're ending now the session more or less on time. We had very interesting discussion, I think diverse point of views. Leo raised some very valid questions. Pantelis provided a lot of technical background. We have the industry's participation with very exact presentation, and we see the difficulties and the challenges actually on the ground. So the transition, I think a general conclusion that could be said that the energy transition to lower emissions is not that easy. It's difficult. There are problems. There are a lot of conflicting facts there. And of course, the consumer is in the middle. And I think the choices for the consumer as we go on will become more harder and more difficult. So thank you very much all for throwing a lot of light into these issues. And I look forward to meeting you all again, and not in the very distant future. So
thank you, Costis.
Now
Thank you.
the next session.
Thank you.
Thank you very much.
Thank you. Bye-bye. Bye-bye. Thank you.